Welcome to the part 8, Oops, the realistic run, which is part of module 6, classes and oops. And this is very important part because here I'm gonna put everything, all concepts, whatever we have learned so far, and to work it with one realistic example. It will be a most exciting and fascinating session. So just sit back and watch it. So it's time to put bits and pieces together and make a ever beautiful and marvelous yet meaningful artifact. As I am talking about Python classes and oops only. You don't need to worry, dude. So let us make one more example, but this time we will write code for that in a systematic and sequential manner using all the concepts whatever we have learned in oops module. Okay, so now what is our agenda? We are going to build a set of classes that do something more concrete, such as recording and processing information about pupil. As you will see, what we call instances and classes in Python programming can often serve the same role as records and programs in more traditional terms. Specifically, in this video, we are going to code two classes. Just note down, kindly note down. One, person. Person is a class that creates and processes information about people. Two, manager. Manager is a customization of person that modifies inherited behavior. In addition to that, along the way, we will make instances of both classes and test out their functionality. When we are done, I will show you a nice example use case for classes. We will store our instances in a shell object oriented database to make them permanent. That way, you can use this code as a template for fleshing out a full blown personal database written entirely in Python. I hope you're getting what I'm speaking. That's fine. So, the main intention to put this is to explore real oops. What is a real object oriented program? How do we use this in industry? So how much it is helpful when we are working. So explore real oops is to demonstrate all of the main ideas in Python's OOP model. Despite its syntax details, Python's class system really is largely just a matter of searching for an attribute in a tree of objects, along with a special first argument for functions. Okay, dude, enough is enough. So much for the design phase. Let's actually move on to implementation. Our first task is to start coding the main class persons. Okay, we will begin with step 1, that is making instance. So here our first task is to start coding the main class. What is the main class? I have told you, kindly recollect it. What I told you, just repeat. It is person. Yes, you're right, it's a person. Okay, let us name our module file as person.py. Okay, actually, of course, you have to write everything in a file so that after that it can be reused. It can be reused. So we will write in a file and we'll name it as person.py, and our class, and we'll write our classes and then blueprint within that file. So now first we'll make the class. We will use a class statement, and then name of the class colon. That's it. Okay, so after making the class, the first thing we want to do with our person class is the record basic information about pupil, uh, to fill out record fields. If you will, of course, these are known as instance object attributes in Python speak, and they generally are created by assignment of self attributes in class method function. Okay, the normal way to give instance attributes their first values is to assign them to self in the init constructor method, which contains code run automatically by Python each time an instance is created. So we have added a name statement, that's the class statement, and we have created a person class. Then we have to build a roadmap or a blueprint to record the information of the pupil. For that, what we have to do, we have to use init constructor. So we have used it, and inside that we have to use self dot whatever the parameters we have given, so that these values will be assigned to the other instances. That's what we have said before. So let's add those self dot name, and then the remaining follows the same. Now notice the argument names appear twice here on top. Here you see here self dot name is equals to name equals to name, job is equals to job, pay is equals to pay. This code might seem a bit redundant at first sight, but actually it is not. The job argument, let us take this example. The job argument, for example, is a local variable in the scope of the init function. Okay, these are basically parameters, and it is a local variable of init function. But the self dot job is an attribute of the instance, that is the implied subject of the method call. So there are two different variables which happen to have the same name. By assigning the job local to the self dot job attribute with self dot job is equals to job. So we have saved the passed in job for the instance for later use. I hope I have been explaining the same thing throughout the module 6 classes and hoops. At least now it should be clear. Okay, and then and finally, one more augmentation to our constructor is we can provide defaults to some of its arguments. So they need not be provided in cases where their values aren't available or useful. To demonstrate that, let's make the job argument optional. Okay, because all people may not work, so that's why we'll set a job argument to the default. So it will be default to the none. You see here, job argument defaulted to none, and pay also 0. That's fine. And then meaning the person being created is not employed. If job defaults to none, we will probably want to default pay to 0, because if he doesn't have job, then how can he get pay? How can he get B paid. Okay. Uh, mm. So we will probably want to default pay to 0 also to for consistency. That's fine. Then what this code means is that we will need to pass in a name when making persons, but job and pay are now optional. They will default to none and 0 if omitted. So I think these first two steps are clear. Now I will move on to third task in making an instance. That is add incremental self-test code. Basically, it is not part of making an instance, but it is vital to know before you work with oops, before you creating a huge amount of classes, before you creating a blueprints, you should know how to add this incremental self-test code. So this is like testing as you go. As we probably begin to appreciate already, programming in Python is really a matter of incremental prototyping. You write some code, test it, write more code, test again, and so on, so forth. So that's what we call it as a testing as you go or incremental self-test code. Because Python provides both an interactive session and a nearly immediate turnaround after code changes. It's more natural to test, so you go than to write a huge amount of code to test all at once. Now, for that, what we can do? How can we make this possible? For that, what we have to do is you have to use the code two ways. I will tell you what are those two ways. Each module can be used either as a script. One way is script or module which will be imported. The second way is as a module. Whatever file we are writing, for example, person.py is the file we will be writing, and this file can be either used as a script. Script means you'll just run that script there and you'll get the result. That is one way. The second way is you import that file and then you access only items or names which are required. So it should not give, when you import, it should not give any result. So these are the two ways of using your file. Now, if you ever decide to import the class in this file in order to use it somewhere else, we will see the output of its test code, because thus far whatever we have written now, if you add self.name, after that if you create an object and then if you call, obviously you will get it. So that's the reason. So we have to be very careful. It should not, your module, when your file imported as a module, it should not show any result. It should only provide an access to the namespace. Now for that, what we'll do is, so it would be better to arrange to run the test statements at the bottom only when the file is run for testing, not when the file is imported. So that's what the module trailing double underscore name leading double underscore check is designed for. As you go, as you learned in the previous videos of the course, so you just revisit our previous videos, and we have discussed about this before also, but here we will be discussing with best with a proper example and more concretely. So this is what we will do when run for testing only. And if you import this file, it won't show any result, because you have put whatever items you want to set, you want to test inside the if block, inside the if compound block. So when you run test, then only these items will be run. If you import this file, these items won't be run because it will only give access to this. Okay, I hope you got that what is incremental self coder. Test as you go. So if name double is equals to main string is very important. From now onwards you have to use this. Okay, just remember this. Anyway, I'll show you while coding in Jupyter notebook. You don't need to worry, but initially you just focus on theoretical aspect, then we will enter into practical aspect. So now we will get into Jupyter notebook. Here it is. Making an instance is our first step. That's what we have discussed in our slide, some of the theory concepts. Now in that, our first subtask is make your main class. Let's make it. Class statement, name of the class, and then colon. Your class is ready. Now okay, so this is better. Making an instance. So now what we'll do is we name the class, but we do not know how does it feel like, how does it look like. We do not know what person class mean. So now we will design our class. We will lay out the attributes and actions in a simple layman language. We will make one category with set of rules. Let me execute this. So for that I will use constructors. Coding constructor, that is the second subtask. So I have made a class, and then in it I have to define the shape and give the features. So I will do that. Now to give state or attribute to the class, what we need is a constructor. As name reflects, it builds a plan or blueprint of attributes of a class. So this is what we'll add a record field initialization. Basically init function is initialization. This is a record field initialization. It took 3 parameters, and then each parameter is assigned to another variable which is self.name. It is a instance attribute. So we have discussed this is not a redundancy. There is a specific purpose to it. That's the reason we are doing this. So we have built our person with attributes. He will have a name. Person category will have name, job, and pay. Now the job argument, for example, is a local variable. It's very clear. We have discussed before also in functions. We have discussed in functions part 2 scopes. We have discussed about the various scopes, local variable, non-local variable, global scope, and everything. You just go back and visit those videos, and then you can watch it here if you have any doubt. So now the job argument, for example, is a local variable here in the scope of the init function, but self.job is an attribute of the instance. There are 2 different variables which happen to have the same name. By assigning the job local to the self.job attribute with self.job is equal to job, we save the passed in job on the instance for later use. I have discussed this topic in our slide, so that's why I'm not explaining here. I hope you got what I'm trying to convey. Then our constructor is ready. So now I want to add some defaults to it. So if job defaults to none, we'll probably want to default pay to 0 just for the consistency, because if the one who doesn't have job, how can he have pay? So here job and pay are zeros. Job is none object and pay is 0. So I'll execute this. With this code, what this code means is that we will need to pass in a name when making person, but job and pay are now optional. Now you don't need to give if you don't want. If you don't give those arguments, by default it will be taken as none and 0. So now the third subtask in making an instance is incremental self-test code. So why we are putting here? Because see, the logic is simple. Whenever you are writing a big file, in that time you will have some doubts. So while writing your file, you will do the testing, but at the end this file should be used for somebody will import this file and then he will use it in his program. So if he wants to use it, and whatever file you have written and whatever test you have written, if they also got executed when they import, then what is the point? So it is not good. So that's the reason we will add a different function, a different name, so that we can make both possible. You can do it self-testing here, and if somebody imports that file, it only gives access to the names. It will not execute these tests. Let's see how can we do. So the first step for us is, I will go to the VS Code, and then in that VS Code I will write the same code, whatever code we have written here. Whatever code we have written there, I will just copy and paste it here. Everything remains same. Okay. So but here what I have done is, I have created an instance. I have instance or object. Create instances or object of person class. First object is Madh, second one is Kesh. So these are the one. Now while I just want to test this, so that's the reason I have added this test. I just want to print name of the Madh object and pay of the Madh object, and then name of the Kesh object and pay of the Kesh object. So I have this two tests have written, just whether my classes and object program is working properly or not. So basically I executed, it's working properly. Now my file is ready. So let's see what will happen. So add incremental self test code, and the first one is without this name function. I have not included any name function in it. So these are the tests I have written while writing my program, and it is done. I have closed it, I have saved it. Now it is open to anybody to import and work it. Let's see what will happen if I import. So when I import mod1, that's the name of the file, it is automatically giving the test results. Of course we'll get the namespace access. But the thing what's happening here is, this is our namespace access. It consists of person class, and then Kesh and Madh are the attributes. But that is fine. That is not an issue. Kesh and Madh are our objects inside the file. But that is not an issue. But whenever I import, these things are also being executed. But this is not the way. We should not give the results when somebody is import. So when somebody is importing your file. So how can we stop doing this? So how can we prevent it? How can we prevent this to happen? So we have one hack, or we have one item to save us. That is name function. Trailing double underscore name, leading double underscore. I simply call it as a name function. Okay. So what we can do with this, now here in this case, we will use name function so that we can write our test cases while developing the program, and at the same time when someone calls that module, this testing is not visible at all to that person, whoever is importing that. Let's see how can we do that. Let me go back to my root folder and create a one more file. The name of the file is mod underscore name.py. So here what I have done is class, and then I have constructed the attributes of the class. It's a layout or blueprint. So with this, my class is ready. So now I want to test it. So this part, whichever I have marked, that is the only piece of code. That's the only piece of code or variables that I want to expose it to the third person who is importing my file. Okay. So now the remaining thing, these all, whatever whatever things are here, these are things I want to use it for the testing. I just want to test whether this piece of code is working properly or not, because if I write the bigger and bigger code, I will have more tests. So first one is I have created an object math, and second one is I have created another object cache, and then I just want to check whether I am able to fetch the instance attributes such as name and pay. So let me execute here. Here you got some name cache is not defined. Okay, these are all not defined here. That's fine. Now I'll save it, and then I'll go back to our Jupyter notebook. What is the name of the file? Mod underscore name. So this is how we import. Let me import that. No issue in imports. So let me now just compare with the mod 1. It did not show any testing output result. If you see mod 1, when you import mod 1, it has given a test results, whatever code I have written to test that file. But here in mod name, in this file it hasn't given any test results. It did not show any test output results. So that is what we want. Now if you see the namespace, you have only person. So but without name variable, we got the object names also, because the object names that we have created for the testing, I don't want them to expose it to the third person who wants to use my module. Okay, so that's done. So that's how we can separate a test as well as module import from our file. So now